My name's Neil, and here at PepperDash I develop products including essentials. Today we'll dig into configuring essentials.
In this video, we'll cover configurable behaviors, multiple systems running the same code with different configuration, manually generating configuration files, and using our tools to generate configuration files.
Let's talk about some examples of different configurable behaviors. So one example might be if you had 50 huddle rooms in a building and they each had occupancy sensors, you might not all want them to use the same triggers from the occupancy sensor and behave the same way. Maybe some of those rooms are outside important people's offices, and maybe they shouldn't be triggered by occupancy sensors to turn off, but they should be to turn on. Or maybe you need them to only operate off the occupancy sensors during certain days of the week or during certain times on those days of the week. The configuration nature of essentials allows you to set the properties for the configuration to control that behavior without having to modify the code. Another example would be emergency system integration, where let's say you have a trigger from the emergency system in the building that's supposed to make the rooms behave a certain way. And in some rooms, maybe all that needs to happen is the sound needs to be muted so that people can effectively hear announcements over the PA system, or maybe we need to shut off the displays in some rooms and power them down in the event of a certain kind of an emergency like a fire. By making changes to the configuration files in those specific rooms, again, we don't have to change the code, we just have to change the configuration file to make the room behave the way we want.
How do we handle multiple systems running the same software? One way we can do it is through the structure of the configuration file. There's two main objects in the configuration file inside this JSON structure. There's an object called template and there's an object called system. The objects have the same structure, and the template will usually contain the most complete data set, but the system will usually contain a subset of either additional data that isn't in the template or the same properties in the template, and the system values will override any found in the template. So let's look at a simple example of how we might want a property on a specific system to be different for each system. So the best example would be the name of the room. So here we have a property inside the system object, inside the room array, and then one of the objects inside the room array, in this case the only one, has a name property of example room. Inside the template, if we look inside the rooms object, we'll notice that there's also one item in the array and that it has a name property as well. So the name property here is really the name of the series of systems or the group of systems that behave similarly, or the template. So what will happen when the Essentials application loads this configuration file, it will merge the data between the template and the system objects, and what it'll get is it'll get a single object where any values found in the room or in the system object overwrite any duplicate values found in the template object. And you might ask, well, how does it figure out which room name should overwrite which room name in the template? Well, that's where the key comes in. So all of the objects you'll see in the configuration files, pretty much all of them, have a key property that needs to be unique to uniquely identify those objects as different within the same collection. So for every other room that was added inside this rooms array, it would need to have a unique room key that wasn't the same as any other room. So that's how the merge algorithm handles overlaying the data. It finds the key value of room 1, and then when it sees the system and it has an item in the rooms array of the system, it sees a key value of room 1, and then it takes any properties like the name and overlays them. Same thing happens here with the occupancy value. So we have a properties object that contains generic properties about any kind of device, and inside that is an occupancy object and then a timeout minutes property of 60 minutes. So we can see that in this case the timeout minutes is the same on the same object in the template, but if you wanted to have one room that timed out a little bit quicker and maybe it shut down after 30 minutes of inactivity, you could change that one system's value to 30 and none of the code would have to change in that room or any of the other rooms to accomplish that. So similarly, the same thing happens for devices. if we take a look at one of these devices, the most common instance of system-specific values for devices is the connection values. So if you happen to be controlling a device, say this is a fake video codec, but say it was a real video codec and you're controlling it via TCP, you might need a unique IP address for each system, of course. So this is how you'd accomplish that. And if we go look in the devices array, we will find the matching device with the same key. And we'll also note that in this case, there is no control properties in this object. So what we see in the system is actually going to get added into this properties object within the template. So what you'll get afterwards is everything that's in the template, everything that's in properties, including this favorites object. In addition, this control object that's inside the properties object in the system version gets inserted into the properties object in the template version. Let's talk about how we can manually generate configuration data for an essential system. It can be done, but it requires a pretty in-depth knowledge of the configuration structure. But I'll give you an example here of a simple device. So here we have an item in the devices array within the template object. And to make this a little more understandable, I've collapsed all the other objects in the editor here. But I'm basically going to copy this object, and I'm just going to paste it below. And we're going to create a second laptop. So the basic config structure here is important to understand. There's some mandatory properties for each object that apply somewhat universally throughout the configuration, but they definitely apply to anything in the devices array or the rooms array. You need to have a key. This is, like I said before, the unique identifier within this collection. This is the value that gets used when later on we'll talk about the device manager. When each device gets added to the device manager, this is the unique identifier that lets us find it later. So we also have a type property, and the type property is what determines the actual class that gets instantiated in the application when it's running. So this is a very specific value, and we'll show you a little bit later how to determine the exact correct value for this. There's a way to do it where you can send a console command to a running program of Essentials, and it will report back all of the valid values. And you can even filter that report to be more specific, you know, everything containing LAP. We have a couple of properties here, whether or not this device has audio and whether or not this device has controls. And then we have a group property. In this case, the group is PC, so this would be grouped with in-room PCs as well and some other PC-based devices. This property is really not ingested and used by Essentials itself, but it's used by the configuration tool we have to group similar objects together. The UID is a property that is being deprecated going forward, but basically it's a way of identifying, if we were to remove this device from the configuration and then later add it back in as the same device, if we set the UID to the same value, the system would recognize that it was the same device and any historical data about the device would be maintained. So that's an example of how you can manually edit the configuration. Again, you need to know the structure. You can look through the source code and you'll find classes that represent equivalent C# representations of this JSON structure for each device type. But it's a bit tricky to manually edit it. It can be done. We've done it this way for a long time, but this was the impetus for developing tools that make this a little bit easier, which we'll talk about coming up next. Okay, so let's briefly talk about some of the tools we've developed to make generating configuration files easier. So here we're looking at the PepperDash portal web interface, and this is our development environment, and I've got a company called Config Tool Testing selected. And right now I'm viewing one of the templates for this company. So To generate a template, what I'm doing is I'm generating the scaffolding or the blueprint for a multiple system environment here. So typically what's going to happen is I'm going to create a template that's going to represent one or more systems that are similar enough in hardware design and behavior that they function effectively the same as far as most end users would be concerned. So what we can do here is we can click the little configuration tab, and it's going to load our configuration tool. So this is a pretty simple system so far. I've just got a control system, an RMC3 added. I've got a display set to be controlled via TCP/IP, and I've punched in the IP address and the port. And I've got the ID of the display, in which case this is a Samsung MDC display, so we need the control ID. So I can do things like I can add a device. So let's add a laptop. And I could add another device. Let's say we'll add a touch panel. And we will add a room to control the behavior of this hardware. So I'm going to add the Essentials Huddle room, which is the simple single display presentation only room type. Okay, so now we've got some devices and we've got our room. So each of the devices have their own configuration. For example, I can go and set up the touch panel to use IPID 3. The display is already configured. There's really not much configuration to the laptop other than choosing the name in this case. But what we can do is we can go look at our timeline editor, and this is what's going to describe the connections between the different devices in terms of audio-video routing. So here there's only one connection to make. I'm going to select the laptop, and I'm going to say any output on the laptop connects to the display on, say, display port in 1. And we're going to say that the signal type is audio-video. So I would do the same thing if I had other sources connected directly to the display, or if they happen to be connected to a video switcher or transmitter-receiver pairs, or any combination of those two that are supported. So if I go back to the huddle room here, I can adjust some things like the default audio device. In this case, we want to use the speakers in the display. I can set the default display. I can select the audio behavior. So we want to say source routes to all the displays, and then I can select the presentation source routing. In this case, it'll be all audio always follows last video. This is where we can enable things like emergency functions. We can set it to shut down the system based on a digital input contact closing on the control system at port 1. You can choose a logo. So here's where I'm going to choose the built-in Essentials logo, but you can also load a logo off the control processor if you put it in the HTML directory or some other URL that's accessible to the processor. I'm going to pick the PepperDash Essentials logo. You can set a password for the tech page, and you can do some things like I'm going to label this room for the main room volume. None of these other volumes apply in this system type. If we had an occupancy sensor added to this system, this is where we would select it and specify the number of minutes before vacancy when we should act on it. There's also some shutdown timers for occupancy, some help parameters in terms of what the help call button text should say and what the help message should say when the user clicks on the little help icon, and some extra features that can be enabled that don't really apply here, but normally you could select the default source. We don't allow laptops as the default source to be selected because they're not permanently connected, but some source that is permanently connected can be the default source, so that when the system gets powered on by, say, an occupancy sensor, this is the source that it'll power on to every time. And like we mentioned before, some of the configurable behaviors are things like, if you want the room to turn on when it's occupied, do you want that to happen on specific days? And do you want that to happen on specific times on those days? So those are all configurable behaviors within the room. So at this point, we can save this configuration and we're off to the races. Now what can be done from here is we can create systems based on this configuration. And now that I've created this system, I can configure this system as well. So if I launch the configuration tool in the system, it automatically inherits all of the configuration from the template. And this is where, if you happen to notice on the previous screens, a lot of these properties had little lock icons next to them, little checkboxes. You can lock properties at the template so that people can't override them at the system level. So here is where, say the IP address of this display in this system is .100. We can change that and save this configuration. And then what will happen is when we go to the system and we go to the files, we can download that configuration file. And what we'll get is something like we were previously looking at when we were manually modifying the configuration file. We'll get a hybrid configuration that has a system object and a template object with the system values we just edited in the system object and the template values we previously edited in the template object. So obviously you can see how using this sort of a tool makes configuring essentials significantly easier. In fact, some of our end users configure their own systems using this tool.
Thanks for watching. Up next, we'll talk about the device model and how we can instantiate devices and interact with them at runtime. Don't forget to hit the subscribe button and the little bell notification icon so you can find out about all the future videos. Talk to you next time.